Okay, everybody, welcome to Physical Science this afternoon. Today we're talking about properties of matter. Okay, and we have had some really good discussion already in this area, so thank you very much. But here for your notes, which you find this on Moodle too, we have, first of all, physical property. Okay, so the technical definition of physical property is characteristics of a material which can be observed without changing the identity of substance in the material. Examples include color, shape, size, melting point, and boiling point. So the color of your hair, there's a physical property. The color of your folder, the color of, color of anything. Shape, how big something is. So you can have a small rock, a big rock. These are physical properties. Things that you might not think of, though, are things like melting points. Okay? So melting point is the temperature under some standard pressure that something will change from a solid to a liquid. And then boiling point would be something changing from a liquid to a gas. Evaporation is also another part of changing from a liquid to a gas, but it's different than boiling point. We will talk about that later too. So appearance is a physical property. Behavior, or how a substance acts, can be. Now, when I think of behavior, I think in chemistry, I'm thinking about chemical properties. But if you're thinking of behavior in this way, then you're right. So, for example, magnetism. Do you guys know what magnetism is? Okay, so here's a nice little, this viscosity doesn't go with that picture. It goes with the picture just underneath this. I'm not sure why it's there. But this is magnets, right? And this picture here is showing the magnetic field. So you know the principal law of magnets is? The principal law of magnets is opposite poles attract, similar poles repel. So that's a physics thing, but since we're talking about magnetism, we might as well hear. So, do you guys know what has magnetism properties? What do you guys think? Yeah, the most common answer is metal. Now, that's pretty good. It's ferrous metals or ferric metals or iron metals, or metals that have iron in them are magnetic, and other metals that are close to iron. But things that aren't magnetic, that is a metal, for instance, is aluminum. So if you ever try to stick a magnet to aluminum, it doesn't work. So aluminum is not magnetic, but a lot of metals are. So that would be one physical property. So for instance, if you were trying to separate a substance that had a magnetic iron in it, what could you possibly use? Yes, a magnet. Because if iron has a magnetic property to it, then it can be attracted by a magnet. So you can pull it right out with a magnet. And we might ask you to do that later on with the lab. Viscosity. Does anybody know what that word viscosity means? Well, it's a little bit easier to look at than it is to just define. So here's a picture of these 5 different liquids here, all have different viscosities. Okay, so it's kind of, how it sticks to itself. How thick it is would be another kind of way to describe it. But this one, you can see it's just dripping very, thick stream. That's not very viscous. So the word viscous is related to viscosity. That's where viscosity comes from. So this one here is, a little less viscous, or a little more viscous. This one you can see is kind of starting to clump together. That'd be more viscous. This is just like a big, if that falls out, it's going to fall out in big chunks. And if this falls out, it's probably going to fall out all in one thing. So viscosity is kind of how thick it is, how much it is attracted to itself. Let's see, that's a physical property that we can use to distinguish between different substances. And then ductility. Does anyone know what the word ductility means? Okay, so ductility then is the ability for something to be stretched into a wire. So this right here is a picture of copper, and these two clamps here on top and bottom are moving away from each other. And you can see the copper is thick down here, but then it's getting stretched. And so this is a very ductile metal. Copper is ductile. And then this one's not so ductile. So I'm not sure what metal this is, but you can see it conformed a little bit to the stretch, because it's not quite as thick. But it didn't take long before the thing just ripped apart. So this would be less ductile than the first picture. Okay, so if we look at physical change then, oh, I'm sorry, we went a little bit ahead. So physical properties such as size and magnetism can be used to separate mixtures. There are 3 examples in your book of doing this on page 55. One of the examples, well, one example is, using a magnet. Another thing that I want to do for a lab on Monday is this. This is a distillation setup. So what's happening here is we have a mixture in here, okay, and it could be a solution, but we're going to try to use the physical property of boiling point to separate this mixture. So what we're going to do, and we're going to do this in the lab, is we're going to have a Bunsen burner that heats this mixture. Now, the pieces are, let's say that there's, a couple different, maybe an alcohol in here, and maybe a water combination in here. Now, alcohol has a much lower boiling point than water does. So let's say that we heat this up to, I don't know, 60 degrees. And, don't take that temperature for, I'm just saying this as an example. It would depend on the alcohol, and it would depend on, pressures and things too. But if we heat this water to 60 degrees, or this solution, is the water going to turn into a vapor?
Yes.
No, right? Because that boiling point for water is 100 degrees Celsius. Boiling point for alcohol is, I'm saying it's 60. What it is, I'm not exactly sure. So if I heat this to 60 but not to 100, what's going to happen is the alcohol is going to come up this tube in gas form, and it's going to have nowhere else to go except for into this. And this is a cooling chamber here. So this is attached to water. And so there's a tube of water that's going around this inside tube here that has a gas in it. So now that gas is going to be cooled down. What's going to happen to the gas? It's going to go from a gas form to a liquid form. And then if you could see that happening inside there, you would see a bunch of little liquid droplets here. And then as they combine and get more and more and more, it starts dripping out the end here. And then so down here, what you have is called your distillate, or distillate, D-I-S-T-I-L-L-A-T-E. That would be pure substance, which in this case would be what? Alcohol or water? It'd be the alcohol. So we could then, when we're done distilling, and there's no more condensation up here at that same temperature, then we could say that we have separated these two substances by a physical means and their physical property of boiling point. Would you like to do that for a lab?
Yes.
Okay, good, because I always wanted to and never got to do it. So we're going to do it now. Okay, chemical property, characteristics of a substance indicating that it can change chemically. For example, if you burn something, that changes it, right? Like you put wood into a fire, right? When that wood is burnt, has it changed? Does it look? Is it totally different chemical? Yeah, it's a lot lighter, right? Where did all the mass go? Did it disappear? No, because there's a conservation of mass that happens. Where it went is the smoke, right? So there's all the mass of the wood that's not there anymore, and that ash has now been turned into smoke. And it's been combined with oxygen. So in order for us to burn something, you have to use oxygen, and then the smoke is a combination of oxygen and other particles. And the black stuff is also a combination of oxygen and the wood. But it's been totally different. It's a total different chemical. It has totally different properties. So that's really how you can determine the difference between a chemical change and a physical change, is if you have a new chemical. And a new chemical will have a different completely different set of characteristics. So let's look at this. You're going to want to, at home, you're going to want to probably copy and paste this into your browser. Let's look at this here real quick, though. And with that song, we'll start here tomorrow. Have a good day.